Right, we're going to start talking about acids and bases more quantitatively, or with numbers now. Sure, you've probably heard of pH before. You'll definitely get a review in that, and also how to calculate pH. So, most acids and bases are going to be dissolved in solution, often in water. All right, water itself technically is neither an acid or a base. It's considered neutral. But water does have the ability to act like an acid and a base. What it can do is it can do something called self-ionization. All right, so it creates the counterpart to a base and an acid. It can provide both to a solution. So when we measure acids and bases, we measure the concentration of OH minus and H plus in the solution. All right, so, and for water, it's actually that hydronium ion that we measure. So a neutral solution will have exactly the same amount of OH minus and the same amount of H plus or H3O plus. All right, and then based on how the concentration of H plus changes, we can measure how acidic or basic a solution is. All right, some important things to know is that when you take the concentration of H plus and OH minus and you multiply them together, you should always get this 1.0 times 10 to the negative 14th molarity or molar number. All right, this is just something to kind of jot down into your notes. And then when we determine if a solution is acidic or basic, we will look at the concentration of the H plus ions alone. All right, so just H plus. So when that concentration is between 1 times 10 to the negative 7th and 1 times 10 to the negative 1st, all right, then I know this is a little hard to think about it, but negative 1 times 10 to the negative 1 is 0.01, and this is 0.000001. All right, so these numbers are actually bigger, so there's more H plus. That's when we call something acidic. All right, more H plus equals acidic. When the concentration of H plus is between negative 7 and negative 14, or 1 times 10 to the negative 7th and 1 times 10 to the negative 14th, we call it basic, or another term you want to be familiar with is the term alkaline. All right, so again, just to show you what these numbers are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So you can see that these are much smaller. So more H plus is acidic, less H plus is basic or alkaline. All right, and we, instead of writing out all of these zeros, a lot of times you see these scientific notation values. So just remember, if that exponent is between negative 1 and 7, negative 1 and negative 7, then we're probably dealing with something that's acidic. If it's between negative 7 and negative 14, we're dealing with something that's basic. All right, so the key is look at that exponent on the 10, all right, especially if you have a 1 in front of your scientific notation. If you don't have a 1 in front of your scientific notation, things get a little bit more complicated, but when you do have a 1, things are nice and easy. Just look at that exponent. So, see if you can classify these as being either acidic or alkaline. So, if you remember, acidic is an exponent between negative 7 and negative 1. Alkaline is between negative 7 and negative 14. All right, so acidic, basic, aka alkaline, acidic, and when you have exactly this number, that's when you use the phrase neutral. All right, so the pH scale that you've probably dealt with before comes from those concentrations. When you calculate pH, you take the negative log of the concentration of H+. All right, so when you see these brackets, that means concentration in chemistry equations. All right, so you'd plug in, you know, the 1 times 10 to the negative 7th. All right. The nice thing is, when you have a 1 out front, that exponent, the negative 7, becomes your pH. You just, because it's negative log, you're going to drop the negative sign, and your pH is 7. That's how we know 7 is neutral on the pH scale. All right, so on your pH scale, 7 is neutral, above 7 is alkaline or basic, and below 7 is acidic. So keeping that in mind, put milk, baking soda, battery acid, bleach, and hand soap in order of increasing alkalinity. All right, so lowest alkalinity, lowest pH. All right, so increasing basicity. So we're going to go from acid to base. So our lowest is going to be battery acid. And then we're going to go to, let's see, next is going to be our milk. And then next on the list is baking soda. Next on the scale is hand soap. And finally, bleach. All right, with these two being acidic and everything else being basic. All right, in class we will go over the more complicated way of dealing with concentration values when you don't have a 1 out front. But so for now, just kind of remember that that exponent is going to tell you your pH. Just drop the negative sign. So practice your classifications here. All right. So the first one is just using a concentration. We've got 1 times 10 to the negative 4th. All right. If you plug that into your pH equation, we know that this is going to have a pH of 4. All right, or you just can remember that that exponent is between negative 1 and negative 7. So either way, there's going to be an acid and a pH of 4. And then identify the following as acids or bases. So give this one a shot. Anything less than 7 is an acid, greater than 7 is a base. And 7 should be neutral.